morning, one and all. This is Dr. Pradipte, and today we are going to see, or today we are going to discuss on a topic of metamorphic rock. This is a part of your subject, elementary physical and structural geology. Might you not find this one in the content, but what is the uh, objective behind taking this metamorphic rocks? Because these all the rocks and mineral are the basic component of the geology. So whatever the process that is operating on the earth is regulate towards and regulate from these rocks. So this is your metamorphic rocks are one of the, you can say, the metamorphic rock is one of the rock among your three different kinds of rock. Lecture to this process. So the process is known as the metamorphism. The process is known as metamorphism. In this lecture, we will going to see how the rock is formed, what kind of temperature condition is formed, what kind of component is there to form this metamorphic rock and all. So this is going to be a lecture on only on a metamorphic rocks. So how the metamorphic rock form? When rocks are baked by the heat of molten magma or squeezed by the movement of huge tectonic plate or by the pressure by overlying thick succession of rock. So this is a condition which is given by the this is a condition which is happen very fastly that when your rocks are baked, when the rocks are baked. So what is, why the rocks are baked? Baked means when you give the heat to the rock, when you given the heat to that rock, the rock is baked. Okay, the rock is baked. So when the rocks are baked by the heat of molten magma or squeezed by the movement of huge tectonic plates or by the pressure of overlying thick succession of rock, your your the alteration has happened. What is mean by alteration? Alteration means change from one mineral to the another mineral. So only change in the physical component, or we can say the structure. Only structure has been changed, not your what we can say the chemical composition has not changed in the metamorphism process. Means if you have a two or if you we can say the if you have a CaCO3, if you have a CaCO3 in your this rocks and it get converted to the another rock, so CaCO3 composition is the same. You might have some another mineral added or another element added, or the composition is altered in between that CaCO3. Maybe the CO and Ca will be altered in between and all. So what happened in metamorphism? So if you look at this word metamorphic, metamorphic. If you break down this word, when you break down this word, meta means change, meta means change, and morph means form. So change in the form. Metamorphic is nothing but the change in the form. So metamorphic rock is nothing but the change in the rock, change in your form. Metamorphic rock is the rock which is formed by the changes in their structure only. Changes in their structure only. That is known as metamorphic rock. That is known as metamorphic rock. So they are the metamorphic rock are altered or changed beyond their recognition. Change in the chemical composition, texture, and structure. So metamorphic rock are altered or change beyond their recognition, change in the chemical composition and texture and structure. So metamorphism is the process. Metamorphism is the process that occur in a rock due to the effect of high temperature, high pressure, and chemically active fluid. So this is a three major component. This is a three major component of the metamorphism. One is the high temperature, one is the high pressure, and third one is the chemically active fluid. Now we will see one by one how these three independent things can be work together. And it's not happen that only the temperature is get change in the form of the rock. Only high pressure is going to change in the rock, change in the or chemically active fluid. So it combinedly work. It combinedly work. So first component is a temperature, equally important, and the source of the temperature. Temperature means you know that what is the mean by temperature. Heat that is formed or heat that is originated from this one. So the source of temperature is either from magma or due to the depth factor. The source of the temperature is either from magma or due to the depth factor. Metamorphism usually results into the change in the minimum composition of texture of rock, which are subjected to the temperature more than 100 degrees Celsius and pressure is more than 1000 megapascal. So, what the metamorphism is all about is the change in a structure. So, for changing those structure, what you need your what we can say the uh, a temperature. What you need a temperature. So, temperature is generally more than 100 degrees Celsius. Pressure is 1000 megapascal. More than. So, metamorphism is usually result in the change in the mineral composition and texture of rock. So, which rock? The rock are generally igneous and sedimentary rock. The rocks are generally igneous and sedimentary rock. So, that is how you are, or that is how you can go with this metamorphism process. You have igneous and sedimentary rock. You have igneous and sedimentary rock which are subjected to the temperature, and this one is going to changes in a different forms. This one is going to change in a different form. Then you have a low grade metamorphism. Then you have a low grade metamorphism. So now you have metamorphism, and in metamorphism also you can have a two different kind of metamorphism. Okay, or more than two. So what the metamorphism is all about? The change in a structure. Change in a structure. So first one is a low grade metamorphism. In geology, the most of the term, if you don't know the terms, if you know the your if your vocabulary is good, you can have you can write down the answer as your own. If you don't know the terminology or if you not read that one, so the what here there is a two kind of metamorphism: low grade metamorphism and high grade metamorphism. So obviously the low grade metamorphism is the metamorphism in a as per we are going to see in a temperature section. So low grade metamorphism is occur at a low temperature range. Low temperature range. So it's occur at about 100 degrees Celsius to 500 degrees Celsius. Low grade metamorphism is occurred at 100 degrees Celsius to 500 degrees Celsius. Then you have high grade metamorphism. Then you have a high grade metamorphism. So the high grade metamorphism is occurred at more than 500 degrees Celsius. More than 500 degrees Celsius. So this is a temperature and pressure condition of metamorphism. This is a temperature and pressure condition of metamorphism. So you can see the with the increasing grade of metamorphism, when the temperature and pressure get high. So this diagram show the condition of pressure and temperature. This diagram shows the condition of pressure and temperature in which diagenesis, metamorphism, and melting are occurred. Three different terms. Now you have three different terms: diagenesis, metamorphism, and melting. Diagenesis, metamorphism, and melting. These three processes involve in a three different kind of rock formation. Okay, so you are what which rock? You are a sedimentary rock involve the diagenesis process. Your sedimentary rock involve the diagenesis process when you have rocks eroded from the source, eroded, erosion and transportation of this one is takes place. So eroded, after the erosion you have a metamorphism, or after erosion you have a diagenetic process which involve transformation of sediment into the sedimentary rock. Transformation of sediment into the sedimentary rock. Then you have a metamorphism. Then you have a metamorphism. And third one is a melting. Third one is a melting. So diagenesis, metamorphism, and melting. Three different kind of processes involve three different kind of rock formation. On the left is a sketch showing the where in the crust metamorphism and melting occur. On the left, it is a sketch which is showing where the crust metamorphism and melting has been occurred. On the right is plot pressure versus temperature. With the pressure temperature region of metamorphism indicated, the broad curve band shows how the pressure and temperature increase with the depth. Too much of the continental crust. Pressure is shown along the left hand side of the diagram equivalent to the pressure in the crust. So second one is a pressure. Now second one is the pressure. First what we seen the a temperature as a phenomenon is a component. Temperature is a component. One of the important component pressure, temperature. Then second one is we are going to see the pressure. Okay, as you know that pressure is nothing but a stress. Okay, stress per unit area. What is the pressure? So you have two different kind of pressure. You have two different kind of pressure: uniform pressure and direct or differential pressure. Uniform pressure and direct or differential pressure. What is the uniform pressure? Uniform pressure is the increase with the depth due to the increase in overburden. Increase with depth due to the increase in overburden. Direct or differential pressure is increase with depth up to the some extent effective in the upper part of the crust. Increase with depth due to the increase in overburden. Increase with depth up to some extent effective in the upper part of the crust. So this is your uniform pressure. This is your uniform pressure. So uniform pressure is nothing but the increase with depth due to the increase in overburden. Then you have a direct or differential pressure. Then you have a direct or differential pressure. Okay. So uniform pressure is act vertically downward and affect the volume of both liquid and solid. Uniform pressure is act vertically downward and affect the volume of both liquid and solid. Then in a direct pressure you in all the direction act in all the direction and affects only on solid resulting into deformation or shape and change in a mineral composition. The third one is a high temperature is also associated with high temperature is not always associated to depth factor. High temperature is not associated with the depth factor in the direct phenomena. Then you have a lithostatic pressure due to the overburden. You have a lithostatic pressure due to the overburden and stress due to the tectonic forces. Stress due to the tectonic forces. This is how your uniform pressure has been acted. This is how your uniform pressure has been acted. How the uniform pressure has been involved? The uniform pressure is means the pressure from the all the sides. The pressure is from the all the sides. That is known as uniform pressure. That is known as uniform pressure. So you have a pressure from all three sides. Okay, so that is known as uniform stress or uniform pressure. Then you have a differential stress or differential pressure. Okay, so you have at one side you have intermediate, at one side you have minimum pressure, at one side you have a maximum pressure. This kind of pressure is known as a differential pressure or differential stress. This kind of stress is known as differential stress. So in a folding and faulting process and in metamorphism process, you involve such a kind of processes, it's such kind of things, and that's why you find a different kind of rocks in a different kind of layers. So the pressure is a component which more affect your or more affect what kind of metamorphic products are there. Now, now this metamorphic rock is always been studied as a derivative product of the some another rock. So in this one, you have a pre-existing rock. You have a pre-existing rock, which will be changes to the another one. A pre-existing rock which will be changes to the another one. So a pre-existing rock, a pre-existing rock is what a pre-existing rock is will do. Pre-existing rock will be given the a pre-existing rock is given the your what we can say the changes to the another rock. Pre-existing rock is changes to the another rock. So that is known as your granite or granite. So granite is changes to the granite gneiss. Granite is changes to the granite gneiss. So when you have a granite, that granite is get pressure from uniform pressure from the all the sides. Okay, what you can see in this picture is the granite is having a pressure from all the sides. Then that granite is get changes to the gneiss. Okay, so when the granite undergoes temperature and pressure, when the granite is undergoes some temperature and pressure, that will convert to the granite gneiss. Granite gneiss. So granite is converted to the granite gneiss. Then you have a structure in metamorphic rocks. Then you have a structure in metamorphic rocks, a foliation. A foliation. When platy, lamellar, or flaky minerals are there, okay. So what kind of structure will be formed in a metamorphic rocks? What kind of structure is formed in metamorphic rocks? A foliation. So what is a foliation? When platy or lamellar or flaky minerals is formed, when the platy, lamellar or flaky mineral is formed, it's a sheet silicate mineral, the mica. That is a sheet silicate mineral that like a mica, biotite and muscovite, fluorite and talc and serpentine. So you have a sheet silicate mineral like mica, biotite and muscovite, fluorite, talc and serpentine. So this is all are the rock which is having a platy, lamellar or flaky mineral. These all are the platy, lamellar or flaky minerals in it. So you have this what we can say the you have a foliation. You have a foliation. So what the foliation is doing? It it arrange your all the rocks or minerals in the all the minerals in your rock are elongated one in a one unidirectional. Now you can see here. You can see here easily. The rock is get or the this mineral crystal whatever you can say is not uniform in size or uniform in their arrangement. What happened when you have applied the pressure from one side, both side? When you apply the pressure from this side, your your mineral get elongated. Your mineral get elongated. So this is how your foliation get occurred. This is how your foliation get occurred. Now you can see that this figure and this figure. You clearly see the difference in this figure and this figure. What is the difference? This is a randomly oriented mineral. So you can see that these all are the minerals. These all are the minerals, and this is known as the randomly oriented mineral. This one is known as randomly oriented mineral, whereas this one is known as, or this one is a perpendicular in direction. The mineral which is perpendicular in direction, and it is a preferred orientation of mineral. It is a preferred orientation of mineral. So it is a some of the fact or some of the things which will be carried out. Then you have a lineation. Then you have a lineation. When prismatic or rod-like mineral, that is a hornblende, tourmaline, etc., occurring in the rock, orient themselves parallel to the one another. So when the prismatic or rod-like mineral, when you have a prismatic or rod-like minerals occurring in a rock oriented themselves parallel to the one another. So lineation is nothing but a rock which will parallelly arrange themselves one another. So now you have a slatic cleavage. This one is a lineation, foliation is a different processes. Lineation and foliation are the different processes. You may already use a slate during your childhood to write down A, B, C, D, and all. Same slate are there. So the slate is formed from the original rock for the slate is shale. From the shale you have a slate. From the shale you have a slate, form of slate. So so original shale. So when you have original shale, you have a what we can say the shale is get transformed. Shale is get transformed to the new mineral or new rock that is known as slate. Shale is get transformed into the slate. So this one is usually formed during the early stage of low grade metamorphism. Usually formed during the early stage of the low grade metamorphism due to the lithostatic stress. This one is usually formed during the early stage of low grade metamorphism due to the lithostatic stress. Then you have a new sheet structure. Mineral tend to be a parallel to the bedding plane during the metamorphism. So usually you have a form during the early stage of low grade metamorphism, that is a slate. So shale is get converted into the slate. Shale is get converted into the slate, and this one is known as a low grade metamorphism. This one is known as the low grade metamorphism. So new sheet like structure minerals tend to parallel to the bedding planes during the metamorphism. However, further deep burial along the continental margin, compressional forces will be cause deformation. So usually you have a shell which will be converted into the slate. Shell which will be converted into the slate. So you form or you have this early stage of low grade metamorphism. Your shell is converted into the slate. Your shell is this is the early stage or early form of the metamorphism. So this is how your slate is formed. So this is the beauty of metamorphism. Now you can see the how the shell is looks like and how the slate is. So slate from the shell you form a slate. From shell you have a slate. Okay, so this is very important in metamorphism that you must know or you must remember this thing that from which rock, from which source rock the metamorphic rock is get originated, because there is a certain processes, a certain derivative of one another. Means you have a shell, so you can find a slate. Slate get again metamorphised and get for a phyllite, and then again phyllite is go for a cyst and nice. So this is a cycle, or this is the different stages which we have. So stages is nothing but the or stages is going to happen. Then you have a phyllites. Then you have a phyllites. So phyllites is usually associated with intermediate grade of metamorphism, where the mineral grains grow large in size as compared to that seen in the slates. These develop as a pronounced foliation where the preferred oriented minerals are seen. So phyllite are usually associated with intermediate grade. So when you have a slate get again get metamorphosed, that is known as your slate or yes, slate or phyllite is get converted. So this develop a pronounced foliation where the preferred orientation mineral are seen. This develop as a pronounced foliation where the preferred orientation mineral are seen. Then you have a cystose structure. Very important one in a metamorphology, cystose and nysos. So both these two by this structure, cystose and nysos structure. So you can have this coarse and headspur, and then if you have maximum stress from this side, your cystosity is occurred. Cystosity is nothing but a lining or orientation. In this condition, you can see that. So if you take this rock and zoom it out, you can see that this minerals is get aligned themselves in a such or in a particular direction. Okay, so this is your cystose structure. This is your cystose structure. So the cystose structure is usually formed during the intermediate and high grade metamorphism. Grain size increase and can be seen by naked eyes. A grain size increases and can be seen by the naked eyes. Grains tends to enlarge with the increasing grade of metamorphism. The grain size increase and can be seen by the naked eyes. Grains tends to enlarge with the increasing grade of metamorphism. The coarse grain sheet structure mineral show preferred orientation. The coarse grain sheet structure mineral show preferred orientation. The grain size is the main difference between the slaty structure and cystose structure. The grain size is the main difference between the slaty structure and cystose structure. So this is what your cystose structure is looks like. This is how your cystose structure is looks like. You have a elongated grain one another. You have a elongated known as your cystose structure. This is known as your cystose structure. Then you have a gneissic structure. Then you have a gneissic structure, equally important as your cystose structure. Okay. So in gneiss structure, what happen? A bending is there. In cystostructure, one another your this what we can say the elongation is there. In a in a cystostructure, what happen in cystostructure? You have a in cystostructure, what you can do? You have a in gneissic structure, you have a band of alternate band of dark and light mineral, alternate band of light and dark mineral. So that is your gneissic structure, gneissic structure. Okay, dark and light mineral alternate bending. That is your gneissic structure. So you usually have associated this gneiss. You usually have associated this gneiss and all with the regional metamorphism. So gneissic structure is mostly formed by the high grade regional metamorphism. Usually formed by the high grade regional metamorphism. That is how your gneissic structure is formed. So where the sheet, silicate, and other mineral like quartz, feldspar, pyroxene are segregated in distinct band of rock known as gneissic bending. So when you have a gneiss structure, what a gneissic metamorphism is do that it arrange your grains in a light and dark color alternation. So you have a light color, you have a dark color. You have a light color, you have a dark color. So light and dark. So this is your micrograph of your structure. So now we are going to see the texture and structure of the metamorphic rock. Texture and structure of metamorphic rock. So slate is one of the slaty is a texture. Okay. So slate is a strongly cleaved rock. Cleavage planes are developed due to the orientation of fine phyllosilicate grain. That is muscovite, biotite, and chlorite. So means slate is formed from the your shale. Shale is having a some layering because shale is mostly formed by the biotite and this mineral. So this layering is also there in a slate also, but individual grains are too fine to visible with the naked eyes. Then you have a overall dull appearance. Overall, you have a dull appearance. So then you have a Phylites. After slates, you have a Phylites. What is mean that what is the Phylite and what is the this Phylites is all about? Phylite is a similar to the slate. Phyllite is a similar to the slate, but slightly coarser phyllosilicate grain. Phyllite is a similar to the slate, but slightly coarser phyllosilicate grains. Grains can be seen in a hand specimen also. Grain can be silicate also. Okay. But this all the value, slate is get converted to phyllite, and this is one of the texture. Then you have cyst and gneiss. What is cyst? Cyst is a parallel to the a cyst is parallel or having a parallel alignment of a moderately coarse grain. That is your cyst. The grain here in a cyst is visible by naked eyes. So this is rocks, mostly metamorphic rock. You have a coarse grains. This one mainly a phyllosilicate and other minerals such as hornblende, and kyanite. So nice. Then you have a gneiss. Gneiss is a coarse grain rock. Grain size several millimeter. So obviously gneiss is formed from the granite, and granite is what we are in an earlier lecture seen the a plutonic rock, a plutonic igneous rock. Means it is formed under the subsurface. It is formed under the subsurface. So under the subsurface, whatever rocks is formed, that all rocks is having a good crystal size, or the crystal size of this all is large. So you have a coarse grain rock, you have a coarse grain rock, the grain size which is several in millimeter, grain size is several in millimeter, and foliated. So planar fabric, either cystosity or compositional layering. So this is known as the foliation or foliated rock. This is known as the foliated rock. Then you have a tendency for different mineral to segregate into layer parallel to the foliation. Typically, quartz and feldspar rich layer tend to separate from the micaceous layer. So you have varieties of the gneiss rock, orthogneisses and paragneiss. Orthogneisses and paragneiss. The rocks which is formed from the igneous rock is the orthogneisses. The rock which is formed from the sedimentary rock, metasedimentary gneisses. So the from which rock your metamorphic rock is formed is also important, and depending upon this you have a different name. So this is your gneisses. Sorry, this is your quartzite. It is comprised of equidimensional mineral, that is quartz and feldspar. So the name of this rock suggests that it is composed by the quartz. The name of this one suggests that it is composed by the the quartz. So quartzite is nothing but a rock which is formed by the quartz and feldspar mineral. So where we have most of the quartz and feldspar mineral in sedimentary rock. So you mostly find your feldspar and this composition mostly in a sedimentary rock. So it get which rock is mostly formed by the this quartz and feldspar? Sandstone. So it may happen the sandstone get converted to the quartzite. So it is a non-foliated rock. Okay, it is a non-foliated rock. What we have seen till now, it's all are the non-foliated rock. Quartzite is a non-foliated rock. Okay, so what is the structure of this rock? The structure of this rock is a granulose structure. The structure of this rock is a granulose structure. So there is a different type of the metamorphism. What we are going to see, different kind of type of metamorphism. So one is your cataclysmic metamorphism. So cataclysmic metamorphism is the type of metamorphism usually mainly due to the pressure. So when the pressure is a main component involved, when the pressure is as the main component is involved, so that is known as your what uh, known as your cataclysmic metamorphism. When two bodies of rock slide past one another along the fault zone, heat is generated by the friction of sliding along the zone, and rocks that is tend to crush and polarize due to the sliding. Cataclysmic metamorphism is more mechanical breakdown of rock without any new mineral formation. However, sometimes due to the intense shearing, few new mineral are formed. So, cataclysmic metamorphism is mainly formed by the your what we can say pressure. Then you have a contact metamorphism. So, what the contact metamorphism will do? This type of metamorphism. So, first one is mostly covered by the uh, pressure, and this one is a contact metamorphism is mostly having a work on a temperature. Okay, temperature is the main component, main phenomena. So this type of metamorphism is occurred locally adjacent to the igneous intrusion with high temperature and low stress. there is a little change in a bulk composition of the rock. There is a little changes in a bulk composition of the rock. The area which is surrounding the intrusion, area surrounding the intrusion is heated by the magma. Metamorphism is restricted to the zone surrounding the intrusion. The zone is known as metamorphic erodes. The rock formed in a non-foliated fine-grained rocks is called as the hornfels. So here the most the mostly reflected here your temperature. The temperature is the main phenomena which is having a domination in contact metamorphism. So this type of metamorphism occur locally adjacent to the igneous intrusion. There is a little change in the bulk composition of the rock. Area surrounding the intrusion is heated by the magma. Metamorphism is restricted to the zone surrounding the intrusion. This zone is known as the metamorphic erodes. So the rock which is in this form is known as the metamorphic rock. So before the deformation, you have a this kind of structure. Before the deformation, you have this kind of structure. After the deformation of rock, you have a this kind of structure. This is your regional metamorphism. This is your regional metamorphism. Okay. So now you have a two different kind of metamorphism. Non-foliated, the example of foliated is slate, phyllite, cyst, and gneiss is the example of foliated rock. Quartzite and hornfels is a non-foliated rock. Non-foliated means there is a no structure, no specific direction and all. So what is the importance of metamorphic rock? We will see very the metamorphic rock cleavage, cleavable soft. Since they are impermeable and split easily, thin, large size slab of uniform thickness can be extracted for roofing purpose. So this one is known for a roofing purpose. Gneiss rocks rich in silica, predominantly quartz and feldspar along the garnet, pyroxene, and this one. Again, you have cyst is cleavable. Natural cyst is main reason for their weaknesses. So all this rock is can use quartzite. Quartzite because metamorphism and sandstone result disappearance of cementing material, bedding place, and fossil content. Quartzite are compact, hard and strong, very less porous and less permeable than the parents. Then you have marble. Marble is a Latin word. Marmor means a shining stone. So you can see the marble, which is always a shine. So this one is a calcareous to the pleasant color and brilliant appearance. The whatever the luster of this rock is a very brilliant one. When polished, it is extensively used as a building stone or to you form a big more a temple and all. So this is your all are your the rocks, different kind of rocks. This is your MCQ questions. This is your MCQ question for the today's lecture. This is your all are the MCQ question. You go to this MCQ question and this one is also in your LMS also. So this is all about the metamorphic rock, a different structure of metamorphic rock, process that is involved in a metamorphic rock, regional and different pressure, temperature, and all are how it can be acted together, pressure, temperature, and chemically active fluid and all. which what is the different use of the metamorphic rock? Like you have a slate, you have a slate, and all this one. So this is all about the metamorphic rock. I hope you understand and learn something from this lecture. So if you want to read about the metamorphic rock, so you have Billings and all these books, okay, Billings and all, where you have igneous petrology and metamorphic petrology are there, or many books. So first you have this Bangal, Parveen Singh and all. This one is also having a good knowledge about this metamorphic process and all, how the rock is has been changes to the another one. So this is all from the today's lecture. Thank you for joining and listening. Thank you all. Now I'm going to close my lecture.